Hi, and welcome to Q's Workshop. Today I'm continuing on the WigWag engine, so this is going to be part 2, and that would be doing the cylinder block. So the part list for the cylinder block calls for a 25 by 25 millimeter aluminium block, and it's 60 millimeters long. And then the very first operation is to trim down the one side to 20 millimeters. So ultimately, parts list wise, I need a 20 by 25 millimeter. And so I've already completed that piece. So all that we're going to do now is head over to the lathe and get this mounted in the 4-jaw chuck, because we're going to be boring through, drilling and boring, an offset hole just to the one side. So yeah, let's head over to the lathe. I already did some layout and markings on the piece as per the build notes. So the very first one is just a line for 30 millimeters. So that's to ensure that I have the part sticking out of the jaws with 30 millimeters. Because the front end of this gets turned down to a cylinder. So ultimately this whole piece up to that 30 millimeter line will be a cylinder. And then it's just to ensure that when I'm putting it in the vise, I actually have it sticking out the amount that I need to be cleaning up. The second markings, I've already punched that. So it's an offset hole, and it's 10 millimeters from either side. So it's offset from the face end this side, it's 15 millimeters. So the idea now is using the 4-jaw chuck to actually have this part offset a bit to the one side, that punch mark is in the center line of my lathe. So I'm going to be fettling around a little bit with the lathe and with a center. So I've got a live center in. I've got another center. So this will get put into the vise, into the chuck jaws. I will be dropping this into the hole that I've punched. The other end will be in the live center. Then I'll be using the dial indicator to ensure that this is centered, because if it's not centered, it will ultimately be going like this, which would mean that my dial indicator will be moving the whole time. So as soon as my dial indicator stops moving, this is running true, which means that hole or the punch mark is in the center line of my lathe. Make it right for the camera. Okay, so now when we turn it, see how it's moving? It's telling me where the high spots and low spots are. Okay, so these two sides are centered now. Now it's just this side to that side. Okay, I think I'm going to leave it there. And that's as good as I'm going to be able to get it. So I just visually checked my center punch there, and it looks accurate. So let's go. Center drill. Then I'm going to take it up to a 7mm, take it up to a 13mm, and then we'll bring the boring bar in and take it up to the 15mm that it needs to be. Alright, that's almost 15. So it's very close to the 15, so that's the 45, and then we've got 1, 2, so 40, well, it would be, it's one round already, so it's 50, 95, 2, so it's 97. Let's check it. Oh, actually, it's more than 97. 99, so 1499. That's what we've got there now. I think I actually hit that pretty perfect. I'm going to leave it there. Remember, the piston is going to be made to fit anyway, so whether I overshoot the size or not, we're going to be making the piston to size. Okay, so next up is the cleaning up of the outside to make the cylinder form. So what I'm going to do now is I'm just going to get a normal lathe tool on here, and I'm going to get the live center in because I want some center support because of this interrupted cut. We want some center support. Right, I think I'm going to leave it right there. Okay, so that's it for the lathe. I think I'm just going to round this corner a little bit. chamfer there. Let's take it out. Perfect. So the next operations are going to be in the lathe, in the mill. So it's going to be to clean up these two faces, kind of to make it round with the cylinder as best possible. I don't have kind of like these round chamfering tools, so we'll see what we can do there. And then for this side, it will be the pivot hole tapped and the cylinder port hole that goes in there. Alright, over at the mill now. So I'm going to start off with the pivot point hole. So that's it's got to be drilled for a M4 tap size. I'm going to be using a 3mm end mill to do that, because I want a flat bottom hole that I'm going to drill here. And that's only got to be 5mm deep, because I can't drill into the cylinder. Okay, so it's got to be a blind hole, and I'm using just an end mill to make sure I get a flat bottom on that. And then I'll use a bottoming tap as well to make sure I get threads all the way to the bottom of that hole. I was lucky enough that I actually have a bottoming 4 mil. It's probably the only one that I've got. Then I will just move up 12mm, and with a 2mm drill I will drill a hole all the way through. So that's the port hole, so that hole goes all the way through into the cylinder itself. So that will be with a 2mm. Then I'm going to turn the part over, and I'm going to use this. So this is just a normal wood router bit, so I'm going to try this and see if I can round the corners on the other side of the cylinder. The aluminium should be soft enough. This is a high-speed steel bit, so we'll see if it actually works. Alright, so let's get on to this. I've already done the edge finding on it, so I know exactly where my center is. I've already moved over the 41.25mm for the pivot point, and then once that's drilled, I will then go over 12 and then do the 2mm hole all the way into the port. Oh, sorry, into the cylinder. Right, that's done. Now it's just to flip the part over that I can do the chamfering of the rounds on the other side. Okay, I think that actually came out pretty nice. A little bit of a ridge there, but it is symmetrical all the way around. I think that looks actually quite nice. I'm just going to clean all of this up, and then I'll get you back at the workbench. Next up is the cylinder cap. So it's a pretty simple part. It's really just cleaning up the diameter to fit into the cylinder. So it has to be a press fit. And then chamfering the other side, more for aesthetics than anything else. So yeah, let's get on to that. Head over to the lathe. Trying to get a bit of a better finish on that. Right, there we go. 18. Literally just under 18. 1499.5, even further than 95. Right, so now it's just taking down the front little piece of this. Only 3 millimeters, so 3 millimeters in has to, the diameter needs to be 15, a press fit into the cylinder. For the next operation, I've just got a shaping slash parting tool in, because I want to get a nice sharp corner at the bottom of this diameter. So I'm going to just see what kind of finish I get taking it down to 15 millimeters with this point. Alright, there we go. I'm sure when I push that on, it will stay. Okay, so let's mark 6 millimeters, and that's where we're going to have to cut it off. But what I'll do is I'll cut it in a bit, put a chamfer on it, and then we'll cut it further. That's it. Right, so that's the two pieces done. I did go a little bit overboard with the radius that was cut here, and that was cut with a router bit, high-speed steel router bit. It was the only one that I've got, so I kind of went with that, but then instead of just cutting the corners off, I thought let's round it out a little bit more. Right, and then we've got the cylinder cap. And that will just get press fit in there. I don't want to press fit it yet, because I'm probably just going to clean up this a little bit more with some sandpaper before that goes in. So just a very fine sandpaper just to remove the machining marks, and then that will get pushed in there at the end. Right, well, that's it for this video. Thanks for watching, and I'll catch you in the next one.